In this video, we're going to look at how to solve radical equations. Just like other equations we've worked with, our first goal when we're solving radical equations is to isolate the most basic part of the function. So we want to get the radical all by itself. After we've done that, we want to square or cube both sides of the equation. Now, we'll square if it's a square root, and we will cube if it's a cube root equation. Then, just like any other equation, we want to solve for the variable. So whatever variable we're given, we want to isolate that on one side of the equal sign. And then our last step will be to check the answer or answers. And we want to make sure we do this especially with radical equations, because these equations can sometimes produce what we call extraneous solutions, which means it looks like a perfectly good answer, but when we go ahead and we plug it in, it actually doesn't make the equation true. We're going to start with a very basic example of a radical equation. And remember that our first step is that we want to isolate the radical. So we want the radical all by itself. In this case, the radical is already isolated. So in order to get rid of that square root, we need to go ahead and square both sides of the equation. So then on the left-hand side, the radical, the square root, and the square will cancel each other out because they are inverse operations, just like addition and subtraction. So we're just left with x. And then on the other side, we're going to square 3 to get 9. So this is our answer. We're going to quick check it. So let's plug that back in. Replace x with 9. So is the square root of 9 equal to 3? And it is, so our answer checks. So we know that the correct answer is x is equal to 9. Next, let's look at the square root of y minus 1 is equal to 2. So again, we want to isolate this radical part. We want to have the radical all by itself, which it is. So at this point, we can go ahead and square both sides. So we're going to square the square root of y minus 1, and we're also going to square the 2. So over on the left, the radical and the square will cancel each other out, leaving us with y minus 1. And here we have 2 squared, which is 4. Now all we have to do to finish solving for y is to go ahead and add 1 to both sides. So we get y is equal to 5. Now before we assume that this is the correct answer, we want to go ahead and plug it in. So in our original equation, we're just going to replace y with 5. So we have the square root of 5 minus 1 is equal to 2. And then remember, the radical is kind of like parentheses in the order of operations. So we have to do whatever operation is under the radical first. So we'll do 5 minus 1, which is 4. Is the square root of 4 equal to 4? And it is, so our answer checks. So we know that this is the correct answer. Now this next equation looks similar to the last one we did, but I want to point out the difference. So you'll notice that this time the minus 1 is not under the radical. And remember that our first goal is always to isolate this radical right here. So before we can square anything, we need to go ahead and move that 1 to the other side of the equation. So we're going to go ahead and add 1 to both sides. So we get the square root of y is equal to 3. Now our radical is completely isolated, so we can go ahead and we can square both sides. So we have the square root of y squared is equal to 3 squared. Again, the radical and the square root cancel each other out, so we're just left with y, and then 3 squared is 9. So we have our answer, y is equal to 9. We're going to plug that in to our original equation and check it. So is the square root of 9 minus 1 equal to 2? Again, we have to do the radical first. It acts like parentheses in the order of operations. So the square root of 9 is 3. Is 3 minus 1 equal to 2? And it is, so our answer checks. So we know that our answer is y equals 9. Next, let's look at the cube root of x plus 2 is equal to 3. So again, we want to isolate the cube root. It's already isolated. There's nothing we need to subtract. So this time, instead of squaring both sides, we need to cube both sides. So we're going to take the cube root of x plus 2, and we're going to cube that. And then we're also going to cube the 3. So over on the left, the cube root and the cube cancel each other out. We're left with x plus 2. And then 3 cubed is 27. And now all we have to do to isolate x is to subtract 2 from both sides. So we get x is equal to 25. Again, we need to check this. So is the cube root of 25 plus 2 equal to 3? So is the cube root of 27 equal to 3? And it is, so our answer checks, so we know x equals 25 is the correct solution. Next, let's look at one where we have radicals on both sides. In either case, both of our radicals are already isolated. We have the radical all by itself. There's nothing else on either side. So what we can actually do here is we can go ahead and square both sides. So we'll square the square root of 10 minus x, and we will square the square root of 2x plus 4. So in both cases, the radical and the square are going to cancel each other out. So on the left, we're left with the 10 minus x, and on the right, we're left with 2x plus 4. So then we need to go ahead and solve for x. So I'm going to go ahead and move this x over. So I have 10 is equal to 3x plus 4. Then I'm going to subtract the 4 from both sides. So we have 6 is equal to 3x. Divide both sides by 3, and we get that x is equal to 2. So let's plug that into both of our radicals and check. Is the square root of 10 minus 2 equal to the square root of 2 times 2 plus 4? Well, on the left we get the square root of 8, and on the right we get 4 plus 4, which is also 8. We don't really need to go any further than this because we can see that they are in fact equal. So we know our answer is x is equal to 2. So in this final example, I want to show you two problems that are similar. The difference is that one is a square root and one is a cube root. So the first one says the square root of y is equal to -1. So remember, we talked about how we can't put something under a radical, like -1, and take the square root because it is not a real number. And so because we can only put 0 or positive numbers under that square root, there's no way we can end up with a negative number unless there was, let's say, a negative out in front, which in this case there isn't. So there's nothing I can plug in for y here that will give me a -1 when I take the square root. So this has no solution. Now with a cube root, that's different because remember, I'm multiplying 3 things together. So if all 3 of them are negative, I can end up with a negative answer. So in this case, I can solve this one because it has an odd root. So I would just cube both sides of the equation, remembering to put everything in parentheses. And then here the cube and the cube root would cancel, leaving us with y. And then here, -1 cubed is -1. So our answer is -1. So with an even root, like here, we cannot have a negative, or we can't have our radical equal to a negative. But with an odd root, we can.